Hello, this is Sabir. The topic of our discussion in this video is first order exact differential equation. In the classification of the differential equation, the exact differential equations are they are differential equation and they are ordinary and they are of order first, and they could be also linear and they can be non-linear. Here is the definition of exact differential equation. The first you have to write the differential equation in this form: m dx, the function of x and y, which is the coefficient of dx, plus n dy is equal to 0. So once you write the differential equation in this form, if the derivative or if the partial derivative of the coefficient of dx with respect to y is equal to the partial derivative of the coefficient of dy with respect to x, if they are equal, then we say that differential equation is an exact differential equation. Let me give you the examples of few differential equations which are exact. Here, the first I will write on the differential equation in the form m dx plus n dy. All I have to do is I will multiply dx on both sides. So this will give me 2 plus x square y. If I multiply by dx, so this will be a dy plus x y square dx. In the next step, we will calculate the derivative of this term, which is the coefficient of dy with respect to x. So this gives me partial derivative, will give me 2xy, and then we will calculate the partial derivative of the term, the coefficient of dx with respect to y. So that's give me also 2xy. So if these two terms are equal, then we say the differential equation is exact. So this differential equation is an exact differential equation. Let's work on this problem. The first, again, I will multiply by dx on both sides. So this will be x dy is equal to x square minus 1/2 y square dx. So now I will move these term on the other side. So I can write m dx plus n dy form. So this will be x square minus 1/2 y square dx, and I will move this term on the other side. So x dy. Now this is equal to 0. Now let's calculate the derivative of this term with respect to y partially. So it will be basically y, because 1/2 will cancel out, and with the negative sign, and the derivative of this term with respect to x. So that gives me basically 1. So as this is a negative 1, as you can see that this derivative is not equal to this derivative. So they are not equal. It means this differential equation is not an exact differential equation. Let me take one more example here. Let's check whether this differential equation is exact. So I can write dy is equal to e to the power x dx. And then I will move everything on one side. So I can write it by e to the power x dx minus dy is equal to 0. Now I will calculate the derivative of this term partially with respect to y. So it's going to give me 0. It will give me 0, and the partial derivative of the coefficient of this, which is only 1 or negative 1, the derivative of this is equal to 0. So 0 is equal to 0. So this differential equation is also an exact differential equation. Here I have one quiz problem for you to practice. Please pause the video for 1 and 2 minutes and work on this problem. Next, we will learn how to solve first order exact differential equation. The process is a two-step process. In the step number 1, I will check whether my differential equation is exact or not. So first I will write my differential equation in m dx and dy form. So I will divide by dx or multiply by dx on both sides. So 2 plus x square y and this is the dy plus x y square, and this will multiply by dx is equal to 0. So here I can identify my m. So my m is basically the coefficient of dx, so xy square, and my n is 2 plus x square y. Now we will calculate the partial derivative of the coefficient of dx with respect to y and the coefficient of dy with respect to n. So m, the partial derivative with respect to y is 2xy, and the partial derivative of n with respect to x is 2xy. So this verifies the differential equation is exact because m y is equal to nx. The partial derivative of m with respect to y is equal to the partial derivative of n with respect to x. In step number 2, we will write down the solution, or we will find the analytical solution to this ordinary first order exact differential equation. So for that, we will consider a function phi x comma y, so that it is partial derivative with respect to y is equal to 2 plus x square y, and it is partial derivative of with respect to x is the coefficient of dx. So I consider a function whose partial derivatives with respect to y is the coefficient of dy term, and the partial derivative of with respect to x is the coefficient of dx term. So my first step will be now to basically integrate this term with respect to y, so that I can find the function phi x comma y. So if I integrate with respect to y, I'm gonna get phi xy is equal to 2y, because I'm integrating with respect to y and treating x as a constant. So this is give me x is a constant, so it's gonna be y squared divided by 2 plus, since I'm treating x a constant, I'm gonna get a function of x as a constant. So constant will have some variable x involved in it. The next I will do is I will calculate the partial derivative of this function with respect to x. That term will go to 0. So this term will give me 2x. So it gave me x y square, and I will write h prime of x. This is our next step. Now I know what is the h of x. The value of phi x, the partial derivative of phi with respect to x is x y square. So I will plug x y square is equal to x y square plus h prime of x, which is which gives me h prime of x is equal to 0, or simply if I take the integration on both sides, I will send me h function h of x is just a constant, nothing else. So now I know the value of this function. So I will plug back that one to here, and that will be my solution. So my solution to this differential equation is function phi x comma y, which is equal to 2y plus x square y square plus 2 plus c. So this is the value of the function. How to write down the solution? So the solution, all you need to do is you need to set this function is equal to 0. So the solution is 2y plus x squared divided by 2 y square plus c is equal to 0. So this is our general solution to our partial differential equation because it has a constant c. So let's solve one more example. So in step number 1, we will check whether this differential equation is exact or not. So to do that, first I will write in a standard form. So x divided by y dy. So I will multiply by dx on both sides. So the natural log of xy plus 1 dx is equal to 0. And then we will calculate the derivative of this term partially with respect to x, which is give me 1 over y, and the derivative of this term with respect to y, which will give me the derivative of natural log is xy time with respect to y is x plus 0. And if I simplify, this is just 1 over y. So therefore, this is exact differential equation. So since this is exact differential equation, we can proceed to the step number 2. So in step number 2, we will like to find a function phi whose derivative with respect to y is equal to x comma y, and the derivative with respect to x is natural log of xy plus 1. Is simply the derivative of the partial derivative with respect to y, because the coefficient of y is phi y, and the partial derivative with respect to x of the coefficient of dx is phi x. So first I will solve this. I will integrate this both side with respect to y. So if I integrate, I'm going to get x time natural log of y, because the integration of 1 over y is natural log of y, plus a function of x, h of x. In the next step, I will basically compute the derivative of this term with respect to x. So this is gives me natural log of y and plus h prime of x. And since phi of x is here, so I can write it here, natural log of xy. So I can write here natural log of xy plus 1 is equal to natural log of y plus h prime of x. Now we have to do a little bit more simplification. So after simplifying the left and right hand side, so I will use the property of the natural log, which is natural log of x plus natural log of y, the product rule, plus 1 is equal to the natural log of y plus h prime of. So as you can see now, this term will cancel out. So therefore I will get my h prime of x. So h prime of x will be natural log of x plus 1. And then this implies if I integrate with respect to x, now I'm gonna get h of x, the function. That will be the integration of natural log of x plus 1 function dx plus the constant of the integration. So after the integration, our function h of x is x natural log of x plus c. So now we will plug that function back here and write down the solution of our differential equation. So let me first erase this piece. So therefore, the solution of differential equation will be this function phi x comma y is equal to x natural log of y plus the function h of x is x natural log of x plus constant c is equal to 0, or this is our solution x natural log of y plus x natural log of x plus c is equal to 0. So this is the general solutions of this given partial differential equation. Next, we will learn a shortcut method to write down the solution of a exact differential equation in one line. And here you can see the problem in the example is an exact differential equation, which we already verified in the previous example. So again, first let me write down this differential equation in the form mdx plus mdy. So it is a x, y, and dy plus natural log of xy plus 1 is equal to dx is equal to 0. So once we have this, so this is a term m and this is a term n. So how to write down the solution? So the first you integrate the term m with respect to x. So natural log of xy plus 1. So we will integrate this one with respect to x. And we will integrate the n term who do not contain x directly. So you can see that here the nx has x directly. So I will write this as a 0 because there is a no term which do not contain x directly. So 0 times dy is equal to c. So all I need to do is I need to compute this integration with respect to x only. So what will be the integration of this function? So if I simplify this function, it's going to be lx plus natural log of y plus 1. So this is the integration of 0 is a constant, so which is going to be a part of that constant. So this is equal to 0. I will integrate this function. So as you can see that integration of this function will be, so okay, so now let's we integrate this function. So if I integrate this function with respect to x, it's going to be x natural log of x minus x. And if I integrate in this function with respect to x, this is a function of y, so it's a constant. So the constant time that x time that constant function, and the derivative of 1 is x is equal to c. So as you can see that this x will cancel out. So your solution of this partial this ordinary differential equation is x natural log of x plus x natural log of y is equal to c. It's the same answer which we obtained in our last example, but here we use a little bit shortcut method to compute that solution. Okay, let's do one more problem. So we will use this shortcut method to find the general solutions of our exact differential equation. So here y prime term means is dy over dt. So instead of the variable x, this time we have variable t. So first we will write that differential equation in standard form or in the form of mdx and dy. So this is a dy plus y minus t dt is equal to 0. So I can write my differential equation in this form by moving t on the left hand side and divide by dt on both sides. Now if I calculate the derivative of this with respect to t is a 1. If I take the derivative of this with respect to y is a 1. So that verify that this differential equation is exact differential equation. Now this is my n, m dx or m dt is equal to m, sorry, and this is my n. So if I have to write down the solution, I will integrate m with respect to t. So y minus t dt, and we'll integrate only the term which with respect to y which contained y directly. So only term which contain y directly is a y. So I will eliminate basically t, because t is a function of t. So that will not be the part of this integration. And this integration will happen with respect to t. This integration will happen with respect to y, and that is equal to. So if I integrate with respect to t, is gonna be yt minus 1/2 t square, and this is a 1/2 y square is equal to c. So this is your general solution of your partial differential equation. Now we have to find a special solution which satisfies this condition. So that means when t is 0, y is 1. So let's plug that one. When t is 0, this term is 0, this term is 0, but y is 1. So it's going to be a 1/2 1 square is equal to c. That gives me c is equal to 1/2. So that's give me the constant c. So I will write down this constant c. So therefore the special solution is yt minus 1/2 t square plus 1/2 y square is equal to 1/2. Here I have one more quiz problem for you to practice. Please pause the video for 1 and 2 minutes and work on this problem. This is also the end of this video. Thank you very much for watching. I will see you in the next video. Bye for now.